When we picture the largest animals to ever walk the Earth, we usually look to the terrestrial dinosaurs. The scale of the Argentinosaurus skeleton suggests we are seeing the absolute ceiling of biological size. This creature stretched 40 meters, about 131 feet from head to tail, sent powerful vibrations through the ancient soil, creating a localized tremor. But measuring an animal from nose to tail creates a visual illusion. Length is a metric of distance, but it doesn't always reflect the true physical mass of a creature. On land, gravity acts as a strict biological governor. Bone and muscle can only support so much weight before the physics of a terrestrial environment become impossible. To find the true maximum for animal mass, we have to look to the oceans, where buoyancy suspends those rules. In 2023, paleontologists in a Peruvian desert uncovered fossils that reset the maximum weight ever recorded for a vertebrate. These remains prove that reaching peak biological scale has little to do with being the longest creature. It is about the ability to pack unprecedented density into a specialized frame. When researchers first unearthed these massive fossils in the desert, they struggled to identify them. The bones were so thick and oddly proportioned, they looked more like geological formations than animal remains. Detailed analysis confirmed these bones belonged to a newly discovered species of ancient whale, Prehistoric colossus. Based on the fragments, scientists estimate the animal reached about 100 feet in length. While massive, 100 feet is a size we've seen before in the fossil record. The anomaly is the weight of that 100-foot body. Current estimates suggest Prehistoric weighed between 180 and 340 tons. This diagram compares that 340-ton upper limit to the 90-ton maximum of Argentinosaurus. Despite being a similar length, the whale carries more than 3 times the mass of the largest known dinosaur. For context, look at Basilosaurus, a 20-meter ancient whale. It represents the sleek anatomy we usually expect from prehistoric marine giants. Basilosaurus was built for speed and hunting. Prehistoric followed a different evolutionary path entirely, prioritizing weight over agility. The existence of Prehistoric shows that peak animal mass isn't always found in fast apex predators. It can result from a radically different, highly specialized set of physical traits. How does a marine mammal hit an estimated 340 tons without growing significantly longer than other whales? The answer was hidden in the few fossils recovered from Peru, specifically the vertebrae, ribs, and hip bones. These bones exhibit hyperdensity. Instead of the porous internal structure common in marine mammals, these fossils are incredibly thick and heavily mineralized. A single segment of this spine holds an extraordinary amount of weight. The cross-section shows a solid, dense structure with virtually no empty space. This weight served a specific purpose. It acted as a biological weight belt for an animal that lived and fed along the ocean floor. This heavy skeleton allowed Prehistoric to remain stable near the seabed. It countered buoyancy, staying grounded without expending energy to fight the current. The extreme mass of Prehistoric was a deliberate evolutionary tool. This density was required for its survival in a very specific deep-sea niche. For decades, the modern blue whale has been the undisputed heaviest animal to have ever lived on Earth. A large blue whale peaks at approximately 200 tons. The upper estimate for Prehistoric colossus is 340 tons. Researchers extrapolate the total body weight by applying the density of the discovered bones to the entire skeleton. This projection shatters our current understanding of biological weight limits. Because we still only have an incomplete skeleton, the absolute maximum weight remains a subject of investigation. The full scale of this species is still being determined. This dense, bottom-dwelling specialist represents a new ceiling for biological mass. Its discovery suggests that the planet's oceans and the dry deserts they left behind are still holding on to titans of a scale that researchers are only just beginning to verify.